Welcome to The Explainer. Today, we're going to talk about a number you think you know, pi. But trust me, there's a whole secret side to it that connects everything from ancient wonders to modern science, and maybe even the fabric of the universe itself. So let's just jump right in with a huge question. What if I told you there's a kind of secret code hidden in the universe? A single number that just pops up in places it seems to have no business being. So to start digging into this, we're not going to start in a math class. Nope. We're going to look at two super weird examples that, on the surface, have absolutely nothing to do with each other. First stop, ancient Egypt. We're looking at the Great Pyramid of Giza. Now think about it. It's all straight lines and angles, right? There are no circles anywhere on this thing. Or so you'd think. But here's where it gets kind of crazy. If you take the distance all the way around the base, its perimeter, and you divide that by its height, the number you get is almost perfectly 2 times pi. I mean, what are the odds? Is that just a wild coincidence? Or did the ancient Egyptians actually know about this universal constant and bake it right into their design? Okay, now let's do a total 180. Forget ancient monuments for a second. Imagine a super simple experiment. All you need is a pin or needle and a piece of paper with a bunch of parallel lines drawn on it. Again, no circles in sight. So you take this pin and you just drop it over and over and over onto the paper, millions of times. And here is the mind-blowing part. The probability that the pin will land crossing one of those lines is exactly 2 divided by pi. It just turns out that all those random tumbles and angles are secretly governed by the geometry of circles. So this is the big question, right? How on earth does the same number connect an ancient pyramid and a random game of chance? Well, to figure that out, we have to rewind. Let's go all the way back to the beginning to a really simple, practical problem that first introduced humanity to pi. Think about it. Early civilizations, the Babylonians, the Egyptians, they were builders. And to build stuff like wheels or pots, or even those big, strong domes for their buildings, they had to get really good with circles. They had a very real-world problem. How much clay do I need? How much stone? They had to figure out the basic rules of the circle just to get anything done. And this is where they all had this incredible aha moment. They realized that it didn't matter if you had a tiny circle or a massive one. If you measured the distance around it, the circumference, and divided it by the distance across it, the diameter, you always got the exact same number, every single time. They had basically stumbled upon a fundamental constant of the universe. For hundreds, even thousands of years, it didn't even have a name. It was just that number. Then, in the 1700s, a Welsh mathematician named William Jones was the first to use the Greek letter pi for it. Makes sense. It comes from the Greek word for perimeter. But it was the superstar mathematician Leonhard Euler who really made it famous, and the name just stuck. So, okay, we've got a name for it, we know what it is, but now comes the next huge challenge. A challenge that would drive mathematicians crazy for literally thousands of years, trying to figure out its exact value. And here's the real problem. You can't just take a ruler and measure a circle perfectly. It's impossible, because the number, it's infinite. It just keeps going and never repeats. So how in the world do you calculate a number that never ever ends? Well, the first person to make a real breakthrough was the ancient Greek genius, Archimedes. He came up with this absolutely brilliant idea. He said, forget measuring the circle itself. Instead, he drew a polygon inside the circle and another one outside it. Then he just kept adding more and more sides to the polygons, basically squeezing the circle between them until they got super, super close to the real thing. And by using polygons with 96 sides, which is a ton of work back then, by the way, he proved that pi had to be somewhere between these two very specific numbers. This was the first time anyone had ever rigorously calculated a range for pi. It's why some people call him the father of pi. Okay, so now we know what pi is and a little bit about where it came from, but let's get back to that original mystery. I mean, Archimedes figured out a way to calculate it, sure, but the really mind-blowing part is seeing just how deep this number is baked into reality itself. See, pi isn't just about flat circles on a piece of paper. Not at all. It's woven into the fabric of the universe. It shows up in Einstein's equations for general relativity that describe how space-time curves. It's absolutely essential for calculating the orbits of satellites that give us GPS. It's literally everywhere. So, what happens if you just decide to ignore this fundamental truth of nature? Well, funny you should ask. There's this great and kind of hilarious real-life story about that. Yeah, luckily, there was an actual mathematician in the room who pointed out how absurd this was, and the bill got stopped. Because here's the thing, you can't just pass a law to change a constant of the universe. The universe doesn't care about our laws. If you actually tried to use 3.2 for pi, satellites would literally fall out of the sky, your GPS would be useless, our whole ability to predict the cosmos would just fall apart. So what this really drives home is that pi is not optional. It's a non-negotiable part of how reality works. And that brings us to the final and maybe the deepest questions about what this number actually is. Mathematically, pi is something called a transcendental number. Now, that sounds complicated, but here's a simple way to think about it. You can get a number like the square root of 2 from a simple equation, right? X squared equals 2. Easy. But you can't do that for pi. There's no simple algebraic equation that just spits it out. It can't be pinned down like that. It feels less like something we invented and more like something we just found, waiting for us in nature. And maybe the best way to see just how profound pi is to look at what's often called the most beautiful equation in all of math, Euler's identity. It is just stunning. In one simple, elegant line, it connects 5 of the most important numbers in mathematics. You've got E, the number for growth, I, the imaginary number, our friend pi, the number 1, and 0. The fact that these 5 completely different fundamental constants all link up so perfectly, well, that's telling us something really, really deep about the structure of reality. And that leaves us with one last, truly mind-bending paradox to think about. We live in a world of perfect, finite things. We can draw a perfect circle. We can see planets moving in these beautiful, predictable orbits. And yet, the one number you need to describe all of that perfection is itself infinite, chaotic, and ultimately unknowable. How can an infinite, unknowable number create the perfect, stable world we see all around us? And that right there is the ultimate mystery of pi.